All right, let's talk about the pseudocode for quicksort. So typically when I write the quicksort algorithm, I break it up into two different functions. The first one is like the sort of like the driver function for quicksort, and then the second one would be like the partitioning function. So let's look at this example array. 3, 6, 5, 1, 2, 4. Sure, something like this, right? Now in this implementation of quicksort, we'll use the pivot selection method that selects the last element as the pivot, right? So our quicksort algorithm, our quicksort function is going to, in this case, take an array, and then it's going to take two indexes, the low index and the high index. In high. So the low index, when we would first call this, we would say, here's my array A, and the low index would start at 0. And then the high index would start at 6, right? Or I'm sorry, 5. And it would basically say we are sorting this entire thing. And this is what allows us, when we call this thing recursively, to say, now I just want to sort this right side. So I want to sort this array A, and my low index is this element and this element, so on and so forth. Now you can implement this slightly differently. You could say, instead of passing this integer pointer, which is the memory address of the first location here, you could say, well, I'm going to pass the memory address of a middle location, very similar to typical implementations for something like merge sort, where you're just passing a pointer as well as like a size associated with it, right? In this case, I'll do it with a pointer and then a low and then a high index, right? Now we know this function is going to do a couple things. The first thing is it needs to pick this partition point, and then it's going to move this index or move this element to its proper location, right? So this is going to produce the sort array of 1, 2, 3, 4, 5, 6. So when we pick 4 as our pivot, we need to move it over to this position, right? Because we can see that's the position it's in the final sorted array. So we need to move it to its correct position. And then we're going to end up with the right side, which are all the elements that are higher than it, and then the left side, which are all the elements that are lower than it. And then we'll say, let's quicksort the left, and then we're going to quicksort the right. Right? So that's essentially what this quicksort algorithm is going to do. So the first thing we need to do is we need to partition this by putting this element in the proper position. And for that, I'm going to write a separate partitioning function. Now when we go to partition this thing, we're going to have to pass in the array as well as the low value and the high value into it, or low index and then a high index into it. And then I have this partition index. This partitioning function is going to have to return back the index where this element ended up in, right? So we're going to assume this partitioning function is going to essentially take this array here, move the 4 to this proper position, put everything greater to the right side, everything lower to the left side. That's what the job of this partitioning function is. It's to separate it based on this pivot location, right? So we are going to need to know the index that partitioning element ended up in, so that immediately afterwards we can do a quicksort on the left side and a quicksort on the right side, which we'll do here just by calling this function recursively. So we're going to quicksort the right side, which is going to be the array A. The low position is going to be the partition index plus 1. And then the high partition is going to be the same high that we had here, high, right? Then we also need to quicksort the left side. The same array. The element that is going to be low, or the low index, is going to be the same exact index. The element that is going to be the high is going to be the partition index minus 1, right? So just to illustrate this a tiny bit more, this quicksort, it's a recursive implementation of it. It starts with this partitioning, it starts with this random array. It's going to pick 4 as our pivot, and then it's going to build the array And it really doesn't matter how these are sorted, but it's going to build a new array where 4 is in the proper position, and then we have the two elements that are higher, 5, 6, right? Not necessarily sorted. And then it's going to have all the lower elements, 3, 1, 2, on the left side of it. And then that's what this partitioning index is going to generate for us. It's going to give us this index right here. This is the final resting place of our partition element. And then we're going to call quicksort on the left side and the right side. And we're essentially saying we want to do a quicksort on these two elements and a quicksort on these two elements, right? That's what these two lines of code here are going to do, right? So first do our partition, then quicksort the right side, quicksort the left side. Finally, this recursive function needs to have a base case that it's converging on. If we take a look at our data here, we have a low index and a high index, right? And we need to be converging on whatever our base case is. So every time we call this quicksort, these indexes, the low and the high, these things will be getting closer and closer and closer to each other. And so you can see that here, right? We're adding 1 to the partition index when we're going to do the right side. We're decreasing the partition index when we're going to do the left side. So each recursive call, these indexes are going to get closer and closer and closer to each other. Our base case ends up being if the low element, or if the low index is greater, or I'm sorry, if the low element is less than the high, then we want to do this logic. Otherwise, we don't need to do anything, right? So essentially our base case here, right? Our base case is when the high is greater than, or when the high is less than the low. That's when we stop executing this quicksort function. Right. So this is the pseudocode for the overall quicksort function. Now let's talk about the partitioning function.